Hey folks, welcome back to some Fluent Python. In today's episode, we are going to go over hash tables, basically the building block of Python dictionaries. So, uh, for intermediate Python, it's a good idea of how the general sense of how it's implemented and why it's so performant. So stick around. Let's dive into some more Fluent Python. All right, so just a note that I am going through Luciano Ramala's fantastic book, Fluent Python, and I've been doing videos for a while, and I'm only this amount of the way through the book. So there's a ton of content in here. I highly recommend the book, that you pick it up. Somebody asked me in a comment when they should start learning Fluent Python. I think it's not great for true beginners. Like you want to get a few projects under your belt, maybe even do some professional software development. It doesn't have to be professional, but you should have worked with Python for a while just so you can appreciate what we're going through here. It's fine to learn as a beginner, but I don't think you'll appreciate it until you get some projects under your belt. So with that, let's dive into hash tables. Okay, so as I was saying, hash tables are very performant. That's why they form the foundation of Python dictionaries. You can see over here, this is the Wikipedia for hash tables. Just look at the search in terms of big O notation, which is a measurement of algorithmic complexity. On average, you have a big O of 1, which means it'll take constant time regardless of the size of the data. Constant runtime. I mean, the runtime might be a very long amount of time. It's not a set amount. It's not like 10 seconds or 10 nanoseconds, but it's going to be constant regardless of the size of the input that you're searching over. And at worst, it's proportional to the size of the data that you're searching over. So very performant, and one of the reasons why hash tables, maybe the reason why hash tables are the backbone of Python dictionaries. Okay, so now I'm in my terminal here. I'm in fish terminal. I'm in an IPython command line, essentially interactive section, and I'm on Python 3.6. If you are still on Python 2, you should only be on Python 2 if you are helping to maintain some kind of code base. And even then, you should probably be trying to move over now at this point to Python 3. All right, so Python has this hash that you can actually just call, and you'll notice it'll return these numbers back. Actually, what is the type of hash? If you have something whose hashes are the same, it's nearly, I won't say always, but nearly always true that they are the same exact object. If the hashes are different, it's very likely they are very different things you're looking at here. So there's the hash of the integer one versus the string one. All right, so now to get a sense of hash tables, I want to build something like buckets, something like that, and say for range 50. Okay, so let's see, this should be buckets. Okay, so this is an array of buckets. So let's start here and notice that this is just a list of buckets, let's say. And let's say I want to put something into there. What I'm doing right now is trying to build out the implementation of a hash table because that's part of the backbone of Python dictionaries. But all right, so let's say we want to insert something. We want a function to insert something into these buckets. So let's make a function insert, and I'll take the hash table and take a key and the value. And so, okay, so basically you need a hashing function. Let's just use Python's hash here. We're going to say that the hash is the hash of the key, and then in the hash table for the hash, which is going to return an integer, remember, you are going to put the value. Okay, and then let's return the hash table. All right, so let's say we want to insert into our buckets like a country code by country and like 100. And so, okay, so list assignment index out of range. Okay, I need to know, okay, so I got this error, index out of range, because the hash of US is some really large number, right? So I need to know something about the size of the hash table that I'm inserting into. And this goes into the actual implementation. So now let's do by modulo, so modulo of the length of the hash table. And so this number should be something, so let's print table size and hash. Okay. And then hash table, and then the hash itself. Okay, so let's see what that gives us. I'm basically just working through this now, seeing if we can reason through it. I hope it's useful to you to see me work through something. No. Nope, 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 nope. Okay, so that's wrong. What is wrong here? Okay. Need to put this on the end. Okay, so let's see if we can insert those countries now. Oh, what do we say? Buckets and US and 10. Okay, so what did we, oh, we returned. Okay. All right, so why did we, oh, we're returning. Okay. Let's make buckets smaller so we can actually see what's going on. So 4 in range 10. This is going to be our hash. Okay, so it put that in there. So let's say, let's make that 1,000. So that's going to definitely be bigger. Okay, so the hash is 10 and 7. Okay, so we'll notice now that this got replaced. We collided with an item that was already in that index and it replaced it. And that's another thing about when designing hash tables, you have to account for collisions and what happens. So let's look at our insert function now. Okay, so Python will override the keys if they do exist, but importantly, we don't know because we took the modular here. We could have arrived at this hash index by some other division because the hash table is growing and changing, and the hash of a different key by modulo of a changed hash table might get us to a value that's the same for an existing hash. So what we want to do is check that when we arrive at that bucket, that we want to see if that key actually already exists, the original key. If it does, then we can override it. If it doesn't, what we want to do is append it into the hash table so that we don't override what's there, because we don't want to unintentionally override what somebody put. So basically what we're going to say is now we have the hash. So for I kv and enumerate, let's say bucket. Okay, and actually, so let's grab the bucket, which is the the bucket is the index on the hash. So what we're going to do is we're going to step into the bucket. We're going to say for all of the things, the keys and the values in the bucket, so key value equals kv, right? So we have the index and we have the keys and the values. So if key equals, oh, we don't want to use key. Let's use underscore key. If the key that we passed in is equivalent to the key in the bucket, then what you can do is replace. Okay. Otherwise, what you need to do, and since we used list objects here, what we'll do is append hash table at the hash at the index, or we already have that, right? So we already have it bucket. So we're going to say bucket. So we're iterating through the bucket, right? So it's the index on the bucket is equal to the value up here. And otherwise, append bucket.append the new value, right? So what we're doing is we're storing things in the bucket in the hash table. We don't want to unintentionally override somebody's things that they put in this bucket. And so we're not doing that. We will append to the bucket if the key is not the same. Otherwise, we will override. So let's try this again. Okay, I'm getting this error because instead of putting things into the bucket, I replaced them in there. So what I need to do is reinitialize. I was storing things in this list, not as key value pairs, but just as numbers. So I shouldn't be doing that. So buckets is equal to, let's reinitialize this. Range 10. So let's start again. Okay, so now if I insert, okay, I get this back. So Mexico is not inserted. So let's see. Let's take a look. Hash modulo bucket is there. So if key bucket I, let's do key value. Oh. So append the key value pairs, but okay, bucket. Oh, I see. Okay, so there's a bug in here. And the bug is to say that what I want to do is in this enumeration, I'm just going to check and see if the key exists. and then I'm going to break out of it. And then let's start with key exists is false. Because what I want to do, these buckets are empty. They start off empty, so there's nothing to enumerate over if they're empty. So that's why I was getting nothing. So let's see. So now here, if key exists, if the key does exist, then in the bucket at the ith location, now you can set the key value. Then else, if it doesn't, in the bucket at the hash, append the key value. So let's see. I think now this should work as intended, or as I wanted to. So list index for each. Okay, so now finally got that to work. This is the function. I didn't need the hash on the bucket. I just append to the bucket. And so now if I want to replace, say, Mexico 11 instead of 10, let's say buckets. Okay. Okay, I want to show you this bug that I wrote into this because it's a little bit subtle, and apparently this entire assignment has gotten me, it's a lot more confusing than I was hoping it'd be. But you'll see what I did here. Hopefully, I've been watching this, and I just want to be honest with these bugs that I introduced. I have on the insert this value is a key word parameter into the function, and I redefined it down here, right? I changed it to value. So my value input parameter is being overwritten by something that I was checking. I don't even need to check this value down here. So I'm only using this to check the keys, so I don't even need that parameter. So that was a bit of a bug, and you want to watch out for this stuff. So now I can override Mexico. I'm going to just override it with an integer now. Okay, great. So now let's put, instead of Mexico, US. Okay, so it's slotted in. And now let's put Germany. Okay, so now these are starting to slot in. Now I can't come up with countries off the top of my head. I'm just trying to see when I get a collision here. So let's go France. Okay, so there, finally got a collision where now it went into the bucket and appended to the bucket. And so I can pull things out. So let's quickly, as the last thing we do, implement a search over this. So let's do a search, and we're going to take the hash table as input. And we're going to take a key. So if we want to search over this, so for B buckets, bucket in hash table. So if, well, what we could do is I bucket in enumerate. Do we even need that enumeration? So we get, for each bucket, we want to look at the things in it. So for I kv in enumerate bucket, let's just print these things first, and we'll see. Key kv. Okay, so search of our buckets, which is our hash table. Let's search for US. 0, 1. Okay, so that's the index that it's printing. Okay, I was printing out the key that's US that I put in and the key value pairs. Okay, so for IKV, so let's print, so let's do key value KV. So if key equals key, and here we might also implement the modulo for the lookup, but I'm not going to do that at this time. Let's just do this, just a basic search. Okay, so that returned US, so that looked good. So if key equals key, then return, I guess we'll return KV. Just return KV. Okay, so if it gets to the end and it doesn't find out of that, let's return none. Finds nothing. Okay, so here's our, we search there, we get the US. If Mexico is somewhere, France is somewhere, and then I don't think we had South Africa. Return none. Okay, so this is, and here's our hash table. This is basically the logic behind how dictionaries work. I apparently had some trouble in this video, and hopefully it helped you out seeing me go through it. So stick around for more Python videos, and next time we actually finish the dictionary chapter of Fluent Python, so we'll be going into character and text-based analysis next. So stick around for more Fluent Python. Thanks for watching.